Hi Year 11s, today I want you to continue working on with your balancing equations. We'll start with spending a bit of time on just balancing equations that have already been written as you were doing last Friday, and then we want to progress on to being able to write a balanced simple equation from scratch. And so let's just practice with an example you should have done from the textbook on Friday. So that example is of zinc and hydrochloric acid giving us zinc chloride plus hydrogen. That should have been the first example. So remember, our first step is to make a list of the elements that we have on the left hand side of the equation. So we have zinc, we have hydrogen, and we have chlorine. So there's zinc, there's hydrogen, there's chlorine. Then we copy that list on the right hand side as well, in the same order, so we can compare them easily. Zinc, hydrogen and chlorine. Then we want to count up the number of each type of element on the left hand side. So let's take zinc first of all. Well, we can see that there's no number in front of the zinc, and that means I just have one zinc. Okay, moving on to hydrogen, it can also be seen that I just have one hydrogen and the same one chlorine. Then jumping over to the right hand side, I need to count up how many I have of each. So on the right hand side I have one zinc. Then my chlorines, I have Cl2, so that means I have two chlorines. And then hydrogens, there's a 2 after the H, so that means there's two hydrogens. Okay, so you can see from our lists that our equation isn't balanced because there's different numbers of hydrogens and chlorine. So the next step is to try and balance this equation, and remember, you can only balance equations by placing big numbers in front of a whole formula. What I mean by that is you can't do the following. You can't put a little 2 there if you want just two chlorines but not two hydrogens, because that has the effect of changing the formula of the substance completely. So the only thing I can do is put big numbers in front of a specific formula. So if I have a look at my list, I have two hydrogens on the right hand side but only one on the left hand side. So I focus on one element at a time and I try to fix that. So how can I get two hydrogens on the left hand side? Well, I do that by putting a 2 in front of the hydrochloric acid. Then the next step is really important. I need to update my list for what that affects. So that affects the number of hydrogens. I now have 2 times 1, which is 2. And it also affects my number of chlorines as well. So I now have 2 times 1 chlorine, which is 2. And now you can see that my equation is balanced because the list of numbers is the same on the left as it is on the right. But just remember that step, you cannot put numbers in the middle of formula, only in front. And do it one step at a time, just trying to fix one element at a time. Sometimes you'll have to go back and change the number again, but always just do it one step at a time. So if you think you've done that if you've put little numbers in the middle of formula for any of the previous examples, go back and check that and make sure that you've done it correctly. Okay, let's do a slightly harder example. And that is the example of what we call the combustion of pentane, which is example E in the questions that you were doing on Friday. These ones are slightly more tricky to balance, and in reality you probably won't be asked to balance anything like this until you get to year 12. But it gives us good practice in balancing equations. So again, first step, make my list of elements on the left hand side. So I've got a carbon here, so I put C. I've got hydrogen, and I've got oxygen. And then I copy that list onto the right hand side. Then I want to count up the number of each element that I have. So I can see that I've got C5. So I've got 5 carbons on the left hand side, followed by 12 hydrogens, and then 2 oxygens. I do the same for the right hand side then. This time I only have 1 carbon, I have 2 hydrogens, and then I have 2 plus 1 oxygen, which gives me 3. So you can see that this equation is not balanced at all. The best way to do this is to balance the number of carbons first of all. And so it can be seen that we've got 5 on the left hand side but only 1 on the right hand side. And remember, we can only add big numbers, so I cannot just put a 5 into the carbon like that. That does not work. And so I need to put a big 5 in front of the carbon to ensure that I now have 5 carbons on the right hand side. Again, next step is to update my list entirely. So I now have 5 times 1 carbon, which is 5. And I now have 5 times 2 oxygens, which is 10, plus my 1, which is 11. So I now have 11 oxygens. Okay, so now my carbons are happy, but still my hydrogens and my oxygens are not happy. It's going to be easier to fix the hydrogens first of all. So you can see I've got 12 on the left and only 2 on the right. So I need to think to myself, any number that I put in front of my water is going to multiply my number of hydrogens by 2 because I've got H2 here. So what times 2 is 12? And the answer is 6. So I put a big 6 in front of the hydrogens. Again, I need to update my list for all of that effects. So I've got 6 times 2 hydrogens now, which is 12. And now I have 5 times 2 oxygens, which is 10, plus 6 times 1, which is 6. So 10 plus 6 is 16 oxygens. And now it's fairly simple to fix the oxygens on the left hand side. And again, you can see that I have O2 here. So any number I put in front of the oxygens, it will be times 2 of that number of how many oxygens I have. And so what times 2 is 16? And the answer is obviously 8. And so I now have 8 times 2 oxygens, which is 16. And now my equation is balanced. So that one is a little bit harder, but again, we always just do it in the same way, updating our list each time and trying to fix one element at a time. Don't look ahead and try and think, oh well, if I put a number there, that's going to change the number of oxygens or whatever. Just go with it, and you have to just take it one step at a time. And once you've got the hang of it, these will be easier. So if you want to pause this video now and do the practice questions of balancing equations that have already been written. And then once you're finished that, we'll move on to writing equations from scratch. So now we're going to move on to writing a balance symbol equation from a word equation. So if you can turn to page 12 in your equations booklet, we will talk through the last worked example, which is the reaction of lithium with water. So when we react lithium with water, you should hopefully remember from the periodic table topic that we get a salt, which is called lithium hydroxide, and our other product is hydrogen. So that is our word equation, and we would have written in our balance symbol equation at the time, but now we need to be able to write that from scratch. The first step in writing a balance symbol equation from a word equation is to convert each of the reactants or products into a symbol. So let's take them one at a time. So the first one is lithium. I looked at my periodic table and I see that the symbol for lithium is Li. So it's pretty straightforward for lithium. Okay, plus water. What's my formula for water? Well, it's H2O. If you're not sure about that, then you can do your swap and drop, knowing that water has hydrogen and oxygen. Hydrogen always has a valency of 1, oxygen a valency of 2. So when we swap and drop, we get H2O. But water is a formula that you should just know so that you can quote it quickly in an exam. Okay, so we've got the left-hand side of our equation already. The next one is lithium hydroxide. And what we need to do is we need to do our swap and drop for this one. And this is a little bit more tricky. And so somewhere maybe above the word equation, somewhere off to the side, if you do your swap and drop for that. So we've got, first of all, we've got lithium, and then we've got hydroxide, which if you look at the back of the periodic table, is OH. Okay, it appears as OH minus, which we'll come to in a second. Lithium is in group 1, and so its valency is 1. Hydroxide has a charge of -1, and so its valency is 1. When we swap and drop that, we end up with Li1, OH1, and because it's a molecular ion, remember we have to put it in brackets. But because those numbers are 1, and I can ignore them, so I can rub those out. And because then there's no number outside the brackets, I can just rewrite that as LiOH. Okay, and then I copy that into my word equation. If you need to rewrite the symbol equation underneath your swap and drop working out, that is okay. And then plus hydrogen. Now this is something you need to be really, really careful of. It can be very tempting to think hydrogen, it's just H. But remember, what property does hydrogen have? It is diatomic. It's diatomic, and so that means we need to write it as H2. If you forget to do that, the balancing of your equation, first of all, will be very difficult. Second of all, will be wrong because you haven't got the correct formula. Okay, so now that we've written our symbol equation, that is a large bit of the work done. But we're not quite there yet because we now need to balance it. So a lot of people just leave their equations like this, but you will only get part of the marks for doing that. So again, our first step is to write down all the elements that we have on the left hand side. So I can see I've got lithium, I've got hydrogen, and I've got oxygen. Okay, and then I copy that list on the right hand side. Okay, next step is to count up how many we have of each on the left hand side. And so we have just 1 lithium, we have 2 hydrogens and 1 oxygen. On the right hand side then we have 1 lithium, we have 1 plus 2 hydrogens, which is 3. So just be careful of that. The element might appear in more than one formula, as it does in this case. And then just 1 oxygen. So you can see that my equation is balanced in terms of lithiums and oxygens, but not in terms of hydrogens. Again, remember the only thing I can do is put big numbers in front of a whole formula. So we can see that I've got 3 hydrogens on the right and 2 on the left. And that means that I need to increase my number of hydrogens on the left. And the only way that I can do that in this stepwise way is by putting a 2 in front of the water. Now I know this is not going to fix it, but it's the only way I can do it by moving up stepwise. Okay, and so I need to then update my list on the left-hand side to which elements I've affected. So I've affected the number of hydrogens. So I've now got 2 times 2 hydrogens, which is 4. And now I have 2 times 1 oxygens, which is 2. So make sure you update the list for every element that you've affected. So that big number has the effect of multiplying everything in the formula by 2. Okay, so now you can see that I haven't fixed the problem of hydrogen and I've actually created a problem with oxygen. So how are we going to fix this problem? Well, we need 1 more hydrogen and we need 1 more oxygen. Perhaps it's easiest to work with our oxygen, so I have 2 on the left and only 1 on the right. And so I can fix that by putting a big 2 in front of my lithium hydroxide. That has the effect of multiplying everything in the formula by 2. And so I need to update my list for everything that it affects. So I've now got 2 times 1 lithium, which is 2. I've now got 2 times 1 oxygen, which is 2. And I now have 2 times 1 hydrogen, which is 2, plus my other 2 hydrogens, which is 4. So you can see now, as a result of putting that 2 in front of the lithium hydroxide, I've fixed the problem with oxygen and I've fixed the problem with hydrogen as well. Okay, so the last thing we need to balance is my lithiums, And I've got 2 on the right hand side and only 1 on the left. And so hopefully by now you can see that to do that, I can put a big 2 in front of my lithium on the left. That has the effect of multiplying that by 2, so I now have 2 lithiums. And now our equation is balanced. So it should be 2 Li plus 2 H2O goes to give me 2 LiOH plus H2. And that is your balance symbol equation. Again, that's a bit tricky. There's a couple of steps in that. But once again, do it step by step and make sure you update that list every time you change something. Okay, what I want you to do now is try to write the word equations for the examples on page 13. You'll need to do this in your notebook and take as much as a page per example. Spread it out, make sure you do your swap and drop and make sure they're correct. Okay, let's look at example 1. We'll do that together and then you can try and do examples 2 to 10 yourself. So example number 1 is potassium plus chlorine goes to give me potassium chloride. So in your notebook now, if you take this down, you can work through this with me. Take a new page in your notebook and say balance symbol equations. And write number 1 and then write out that word equation so you know where your equation is coming from. And it's also easy to work underneath each part. Okay, so the first step is that we convert each of our symbols into each of our terms into symbols or formula. The first thing we've got here is potassium. I looked at my periodic table. The symbol for potassium is K. Then I've got chlorine. Chlorine is Cl. But again, we've got a problem here in that chlorine is diatomic. So I must write it as Cl2. Please do not forget that. At the top of page 13, there's a list of all the diatomic elements. Make sure you know those. Make sure you know their position on the periodic table that we looked at last week. And make sure you don't forget them when writing an equation. So potassium plus chlorine reacts to give me potassium chloride. Now, for potassium chloride, I need to do my swap and drop. Potassium is in group 1, so it has a valency of 1. Chlorine is in group 7, and so it has a valency of 1. So when I swap and drop, I get K1, Cl1, but then I can just ignore my 1s, and so it's just KCl. But I need to do that swap and drop to make sure that my formula is not KCl2 or KCl3 or anything like that. So my formula is KCl. Again, next step is to make a list of my elements on the left hand side. So I have potassium, so I write that as K, and I have chlorine, Cl. Again, copy that on the right hand side. Next step is to count up how many of each type of element I have on the left and then how many I have on the right. So you can see that I have 1 potassium and I have Cl2, so that means 2 chlorines. On the right hand side, I have 1 potassium and 1 chlorine. So 1 potassium, 1 chlorine. Now again, you may be tempted just to say, oh well, I need to fix my number of chlorines, but my potassiums are fine, and so I'll just put a little 2 here. But the formula you get from your swap and drop is the actual formula of that substance, and you can't change the formula of that substance by just adding a 2 after the chlorine. So again, you can only put big numbers in front of a whole formula. And so how am I going to fix this? Well, I have 2 chlorines on the left and 2 on the right. The only way I can do this is by putting a 2 in front of my potassium chloride. That has the effect of multiplying both my potassium and my chlorine. So 2 times 1 potassium is now 2. 2 times 1 chlorine is now 2. Make sure you update your list so that we can keep on track. So now I've fixed the problem of my chlorines, but I have, as a result, created a problem with potassium. So I have 2 potassiums on the right hand side and only 1 on the left hand side. So I need to put a big 2 in front of my potassium here and update my list. And now my equation is balanced. So 2K plus Cl2 reacts to give me 2KCl. Okay, so have a go at the equations 2 to 10. Again, spread it out for each of your terms in your equation. Make sure you convert it to the formula one by one. You'll need to do the swap and drop for a lot of the cases. For example, question 10, you will need to do swap and drop twice. The only thing you'll need to know there is that hydrochloric acid, its formula is HCl. We'll look at that in our next topic. But that's for examples 9 and 10. So make a little note that that's the formula of HCl. So when you're writing those equations, it will be whatever your formula is for sodium hydroxide plus HCl gives me sodium chloride plus water. So have a go at those now and see how far you can get with them. And if you're struggling, you have plenty of worked examples to look back on pages from pages 11 to from pages 10 actually to page 13. You've plenty of worked examples to look back on, and make sure your stepwise order is listed there as well on page 10. Make sure you just do each step at a time.